In this video, we'll be looking at section 0.7, function families. And our essential question is, how can I identify which function family in equation or graph belongs to? How can I identify which function family an equation or graph belongs to? So we'll have three categories. We'll have the family, and that's where we'll also give like a word definition. Let's see. We need the most space for graphs. Let's go about there. I think that'll be wide enough. Like so. Okay, so we have 5 families. And the first family we're going to be talking about is linear. And for our linear graph, our definition is the largest exponent of x is the hidden one, or y equals a constant. So what linear equations look like is it could be y equals 3x plus 4, y equals 1/2 times x minus 8. These are all just examples. Or we could say y equals 6. So my highest exponent is that hidden 1 on every x, or y can equal a constant. And our graphs, let's make that a negative 1/2. And our graphs look like this. We can have something like that. We could have something like this. Or we could have our constant graph that looks like that. And that's linear, the linear family. Our next family will be let's go with quadratic. So quadratic the largest exponent of x is 2. So some equations this could look like. The most simple would be y equals x squared. You could have y equals x squared plus 3x plus 4. We're going to have y equals parentheses x minus 8 squared. So notice how the largest exponent for x is always that 2. And we have two different types of graph for this. The first one looks something like this. This is the positive x squared. And then we could have one that looks downwards like that, and that's a negative x squared. And that's quadratics. Let's add some kind of like shape characteristics. Linear, our lines, and quadratic are considered U-shaped. Next we'll have exponential. In our exponential graphs, the exponent is the variable x. And these I consider to be ramp-shaped. We'll talk about what that means once we draw a picture. So some equations that they could look like is y equals 2 to the x, y equals 1/2 raised to the x plus 4, or y equals negative 8 to the x minus 7. So the main thing that we can identify is that they all have this exponent that is the letter x. We got a few pictures. Technically 4 different types. So we have where our ramp is going up. From left to right, we're increasing. From left to right, we're decreasing. And then we can just flip it over the x-axis. So we could look like so, or we could look like so. Like that. That's our 4 different types of exponential graphs. We have 2 more families to do, so we'll do that on the back. Our next one is going to be absolute value or linear absolute value. Let's create our chart. Where did I go over? So we have our family, our equation examples, and our graph examples. And this one's going to be absolute value. And the absolute value is a linear equation with absolute value bars. And these are V-shaped. Okay. So our different kind of equations can be y equals the absolute value of x, y equals the absolute value of x plus 2, y equals absolute value of x minus 4 on the inside, minus 8. We could even throw numbers on the outside. Negative 2 absolute value of x plus 7. So anything that has an absolute value bar is going to create an absolute value equation. And we essentially have two different kinds. And they just look like V's. They're very similar to our quadratics, but instead of having curvature to them, they're just straight lines. And we can have them opening upwards, and that's our positive ones, or we could have them opening downwards, and these are our negative ones. And then we're to our last family. And our last family is piecewise. And in this family, it's made up of multiple pieces. So a piecewise graph is a graph that is made of multiple pieces. So therefore, an equation has to be made of multiple pieces. And these equations will look something like this. And the way what this is saying is that when x is less than 4, I graph this line, and when x is greater than 4, I graph this line. So our picture would look something like this. I'd have a line going up. That's this piece. And then when I get to 4, just assume this is 4, then I would graph this. So it can be made of multiple pieces. And we could have more than one piece or more than two pieces. I could go down, and then I could go up, flatten out, down, and then up again. So I would just need 1, 2, 3, 4, 5 equations written like so. And that's what a piecewise function looks like. And those are our 5 families. It might, like the best way to probably study for these would be to make flashcards. So you could put like just the name on the front side, and then just put some equation examples and some graph examples on the back side. Maybe even the definition. That way you can use flashcards to study. But that is our 5 function families with definitions, equations, and graphs to represent them. And that's how we'll learn about this. So thank you very much for watching this video. I hope you have a great rest of your day.